Hi everybody. So this is the first lesson of Unit 3, and Unit 3 is going to look at quadratic equations for the first 2 lessons, and then our last 3 lessons are going to focus on exponential and logarithmic functions. Okay? So before we look at quadratic equations, it's really important to look back on what we just did in our second unit, and that was factoring. What we looked at was we factored equations that look something like this into a more clean format, one that is very important when we talk about solving quadratic equations and graphing them. Okay, and in that last lesson, 2.5, we figured out how to determine what A and B are. So I'm going to go over that again. At the start of this lesson, we're going to go over those pieces of factoring. If you are comfortable with them, you can skip. Remember, I have timestamps in the comments for each of these videos. You can skip to the timestamp labeled solving quadratic equations. Otherwise, what you're going to see will be a review from what we did last unit, at least for the next few minutes. Okay? So let's start by looking at factoring. So remember, there were 2 options when we looked at factoring. We started with our equation, in this case, x squared plus 9x plus 20. And the 2 options were whether or not the coefficient behind the x squared term was 1, which in this case it is, or a different term, 2, 3, 4, any number that's not 1, basically. Okay? So my first example here, again, this isn't going to be a full lecture compared to our previous lesson 2.5. I'm just going to go over the basics of them. So what we had to do when we factored was we had to look and see what numbers multiply to give us, in this case, positive 20, or the constant, which is the term labeled as C in the general form of the equation. And they have to add up to the constant or the coefficient that sits behind the x term, which is usually labeled b. Okay, remember the coefficient behind the x squared term was labeled as a. So they have to add up to 9 and multiply to positive 20. In this case, we can see that plus 4 and plus 5, these are all the different factors here. Plus 4 and plus 5 multiply to positive 20. And they add to positive 9. So those factors work. Now what you do to factor these, again, these are the neat and tidy examples, is you simply write them as x plus the first factor in brackets, multiplied by x plus the second factor in brackets, in this case x plus 4 and x plus 5. And if you want to check whether your answer is right, you can use FOIL. Remember, it's multiplying the first terms in each bracket together, then the outside terms, then the inside terms, followed by the last terms. And you should arrive at the same answer or the same equation you had at the start. Otherwise, what you did was incorrect. Okay? So looking at a quick example, factor x squared plus 2x minus 3. So what we're looking at is we're looking at factors of minus 3. And they have to sum to positive 2. Okay, so starting with the first ones, minus 3 and positive 1 would multiply to minus 3. They sum, though, to minus 2. So we're close. We're looking for positive 2. So our next set of factors, positive 3 and negative 1, those multiply to negative 3. And they add plus 3 minus 1 is positive 2. So we see that that works here. Okay. So knowing those are the 2 factors, remember, we have our 2 sets of brackets with an x term, and we simply write in those factors in order to factor it. So this becomes x plus 3 and x minus 1. And if you want to check whether this is right, again, you can use FOIL. So our first terms, x times x, gives us x squared. Our outside terms, x times negative 1 is minus x. Our inside terms, positive 3 and positive x gives us plus 3x. And our last terms, positive 3 and negative 1, give us minus 3. So simplifying this, we get x squared, and then we have minus x plus 3x, which is plus 2x, minus 3. So you can see we ended back at the equation that we started with. Okay, that's just to check your work. The second option we had was factoring general trinomials. Okay, in other words, remember we had ax squared plus bx plus c. This is also the general format for a quadratic equation. Okay, so this is going to be the format you're going to see most once we talk about quadratics after this factoring. So we have two options in this case. The first option is if you have something like 3x squared plus 9x plus 6. All of them have a common factor in them, and that's 3. 3 happens to be the coefficient in front of the x squared term, or the a term. So if you factor out the 3, you're left with x squared plus 3x plus 2, and you can factor it just like you would normally, okay, because you have a 1 behind the x squared term. Looking at the factors for this, positive 1 and positive 2, they multiply to positive 2, and they add to positive 3, which is the coefficient behind the x term. So if they do that, we can factor this then simply as 3 times x plus 2 and times x plus 1, okay? So that's in the more easier case of general trinomials. The second option is if you can't pull out that common factor. So if we had 4x squared plus 13x minus 12, you can't pull out a common factor because there's no common factors that factor into 4, 12, and 13. You can take this 4 and factor it out of the constant term in this term, but you can't factor a 4 out of 13, okay? You'd end up with a fraction. So what you do in this case is you multiply the a, or the coefficient behind the x squared term, by the constant, which is c. And if you do that, you get minus 48. So now instead of finding the factors that multiply to negative 12, you're finding the factors that multiply to negative 48, okay? And they have to, just like they did in the past, add up to the middle term, which is positive 13. In this case, we have multiple different types of factors, but the one that we can see that stands out is 16 times negative 3 is negative 48, and it adds to positive 13, okay? So we know that those are the two factors. Now, instead of simply putting those in brackets, what you do is you actually write them out in the equation. So you replace 13x with the two factors, plus 16x and minus 3x. You can see that by adding those two together, you would arrive at the original number of 13x. Okay, so it's the same thing, I'm just writing in a different form. Now with that, you can see, remember in Unit 2, we talked about factoring by grouping. So you can group the first two terms and the second two terms together and factor out individual pieces of them. In the first two terms, you can factor out a 4 and an x. So you're left with x plus 4 after it's factored out. In the second terms, you can factor out a negative 3. The negative is important, okay? Because if you factor out a negative 3, you're left with x plus 4. And what you want is both them to have the same term in brackets, because that means you can factor that term out of both them. So if you remove the x plus 4, you're left with just the terms that are sitting behind them, which is 4x minus 3. Okay, so this is the more advanced case, but again, these are all when you can factor and obtain clean numbers that are, whole numbers that are not fractions, not decimals, okay? Or in some cases where you won't have any roots at all. So again, let's look at one example of this. Factor 2x squared plus 6x minus 8, okay? So in this case, we can actually factor out a 2 from each term. And if we do that, we get 2 times x squared plus 3x minus 4, okay? So I've simply factored out a 2 from all three expressions. And now we have a term here with an x squared and a coefficient of 1 behind it. So we can factor it just like we normally would. So the factors have to multiply to negative 4, but they have to add to positive 3. Okay? So looking at this, we can try negative 4 and positive 1. Obviously, that stands out the easiest because negative 4 is sitting right here. That multiplies to negative 4, but it adds to negative 3. So we can try the opposite of that, positive 4 and negative 1. Positive 4 minus 1 is positive 3. Okay, so we know those factors work. So again, because we have just a 1 or a coefficient behind the x squared term, we can simply write this as 2, and we can directly factor it. Okay, so x and x into each. So x plus the first factor, which is 4, and x minus 1 for the second factor. Okay? So the reason that I showed you all of those steps on factoring, the review of factoring, again, if you want to do a more thorough review, lesson 2.5 goes into even more detail with more examples. But the reason the factoring is important is now we're going to talk about solving quadratic equations. Okay, so the format of a quadratic equation is one that you've seen before. It's the ax squared plus bx plus c. And in a quadratic equation, we have that equal to 0. Okay, so in other words, one side has all of the terms of the expression, and the other side has none, so it's just simply 0. And what we're looking for here is when we factor the equation, okay, so let's say going back we had x plus 4 and x minus 1. What we're looking for are the terms that cause this expression to be true. Okay, in other words, what values of x will make that expression true? And what we see is by factoring it into two sets of brackets, we find two numbers that will give you a value of 0. Okay? How we solve that is what I'm going to go through in these steps. So if we have an expression, let's say, x squared is equal to 4x minus 3. Okay? We can do the following steps to solve it. So the first step, remember, we want it to look like this. And in order to do that, all the terms have to be on one side. So the first item we have to do is take this expression and move both terms, the 4x and the negative 3, to the other side. Remember, if we're adding or subtracting from either side, what we have to do is if we want to move it, we're going to subtract 4x, okay, so 4x minus 4x, and we're going to add 3. Okay, and again, what you do to one side of the equation, you have to do to the other. So minus 4x plus 3. And if you do that, you get 4x minus 4x is 0. Negative 3 plus 3 is 0. And on the left side, we have x squared, and then we have the remaining two terms, minus 4x plus 3. Some of you may see this done a little differently in that instead of all this, you can simply move these to the other side of the equation and change the sign. So if it's positive 4x, it becomes negative 4x. If it's negative 3, it becomes positive 3. Either way you approach that is fine, okay? But just know that when you do it this way, what you're actually doing is adding or subtracting from both sides, because what you do to one side of your equation, you have to do to the other, okay? So now that we have that equation equal to 0, in this case, we can simply factor it, okay? Because we have x squared minus 4x plus 3, so we actually have two numbers that multiply to positive 3 and add to negative 4. Okay, so negative 1 and negative 3 multiply to positive 3, and if you add them up, they give you negative 4. So our factors become x minus 3 and x minus 1 equals 0. Now what this creates is two instances where this function is true. The first instance, all right, is if this first set of brackets, x minus 3, is equal to 0. Because you're either going to have 0 in the one bracket multiplied by x minus something, or 0 in the other bracket, okay? And the only way that that's achieved in this case is if whatever is in this bracket is equal to 0. So we have two options here. X minus 3 has to be equal to 0, or x minus 1 has to be equal to 0. Those are the only two options that will allow this left side of the equation to equal the right side, which is 0. If we do that, all right, we know that x equals 3 and x equals 1 are solutions. And when I say solutions, I want to show you what that means. So here on the right-hand side, this is x squared minus 4x plus 3 graphed, okay, in an x and y plane. And what we do when we set this function equal to 0 is we're finding the x-intercepts. In other words, where this graph crosses this axis here, the x-axis, okay? And what we've noticed here is that x equals 3 and x equals 1. Well, if you look at this graph, the 2 points are right here, x equals 1 and x equals 3. Those are the points where it crosses that axis, okay? And it's always going to cross it on 2 points if it's crossing through, okay? And that's because it's a parabola. So all of these give this U-shaped, okay, parabola. The only instance where it'll only touch once is if the very bottom of the parabola were to touch the axes, okay? And we'll get into those options later on, okay? So if we're looking at solving the quadratic equation, we're going to, again, need to use factoring. So what I'm going to do is give you some examples here. I want you to have to rearrange the equation appropriately and then solve for what the values of x are that would solve this equation. In other words, this is solving for what, again, the x-intercepts are, okay? Where it crosses the x-axis, okay? So where it crosses this axis here, okay? Usually you could point here and point here, or point here, etc. Okay? So our first question is solve negative 5x minus 6 is equal to x squared. First thing we notice here, all the terms are not on the same side of the equation. So I'm going to actually move these two expressions to the other side. So if we do that, we have negative 5x minus 6 is equal to x squared. So we can move them to the other side, and if you do that, you have to switch the side. So in other words, moving this to this side becomes positive 6 from negative 6. Moving this to this side, negative 5x becomes positive 5x. Okay? And if with nothing left on the left-hand side, it simply becomes 0. So what we end up with is 0 is equal to x squared plus 5x plus 6. Okay? Moving those expressions to the other side of the equation. So now we have a quadratic expression, and we can see whether or not we can factor it. So the factors have to multiply to positive 6, and they have to add up to positive 5. Okay? So first item I'm going to try, positive 6 and positive 1. Adding these up gives you positive 7. So our next factor to try, number's too high, positive 3 and positive 2. You can see I have both positives because this number is positive. So my only option is either both positive or both negative. But since the second number here is also positive, I'm staying away from the double negative factors because I know it won't add up to a positive number. Positive 3 and positive 2 multiplies to positive 6, and it adds to positive 5. So you can see here that that works. Substituting that in, we get that 0 is equal to, again, x plus the first term, 3, times x plus the second term, which is 2. Okay, so now we see we have two instances here where the left hand and the right hand side are going to be equal. Okay, we have if x plus 3 is equal to 0, or the first term in brackets, and if x plus 2 is equal to 0. So if we solve for each of these, again, by moving the number to the other side of the equation, we get that x is equal to negative 3, or x is equal to negative 2. Okay, those are our two options in order to solve this equation. So in other words, our x-intercepts, you're going to see later that they're usually written with x and y. So our y term is 0 because we're crossing the axis here. So our x-intercepts would be negative 3 and 0, and negative 2 and 0. And those terms become important when we look at graphing in our next lesson, quadratic equations. Okay? So let's look at our second example. We have 3x squared minus 2 is equal to negative 5x. Our first step, like we've done, is to gather all of the terms on one side of the equation. So we have 3x squared minus 2 is equal to negative 5x. I want to move the 5x to the left side of the equation, meaning it changes from a minus to a plus 5x. And I arrive at 3x squared plus 5x minus 2 is equal to 0. Okay, so now I have all the terms on one side and 0 on the other. So we see here that behind the x squared term is no longer, it's not just 1, okay, it's 3. So what we do is we have to multiply 3 times negative 2. Okay, so the constant multiplied by the coefficient behind the x squared term, and that's negative 6. So we're looking for factors that multiply to negative 6, but they still have to add up to positive 5. Okay? So in this case, I can start with negative 6 and positive 1. They multiply to negative 6, but they add to negative 5. So it's the opposite, meaning if I try positive 6 and negative 1, that still gives you negative 6, but it adds to positive 5. Okay, so in this case, those two factors work. What you then have to do is write the middle term, the 5x term, in terms of those two factors instead. So this becomes 3x squared plus 6x minus x minus 2 is equal to 0. You can see that all I did was write them in terms of those factors. And if you were to add those up, 6x minus x gives you the 5x that we started with. Okay? So now you can factor these by grouping them. Okay, so the first two terms have common factors, and the second two terms have a common factor. So the first two terms have 3x in both terms, which means we're left with x plus 2. The second two terms have a negative 1, so we can factor out the negative 1, and we're left with positive x plus 2. Okay? So that means we have two terms, both of which have an x plus 2 multiplied by them. So we can factor out the x plus 2. And what we're left with are the remaining terms behind each of those terms, which is 3x and negative 1. So we have our two terms by factoring here. And in this case, that means our x-intercepts are the values that solve this equation will be solved with x plus 2 equaling 0, or the other term in brackets, 3x minus 1 equals 0. So in the first case, x is simply negative 2. That's moving the 2 to the other side of the equation. Second one involves one more step. So moving the negative 1 to the other side of the equation, we get 3x equals positive 1. And solving for x, we divide both sides by 3. So the 3's cancel on the left side, and we're left with x is equal to 1 divided by 3. So again, if we want to write these as x-intercepts, what this means for the first term is negative 2 and 0. Again, writing them as x and y terms. Because when you cross the x-axis, you're at the point where y is 0 here, okay? So all across here, you're not moving up or down in the y direction. So the first term would be negative 2 and 0. The second term would be 1 over 3 and 0. Okay? So, so far, solving this equation, we've always had a very neat and tidy solution. It's always been nice, neat numbers. X is 2 or negative 2. But what if it's not? What if it's something like 0.12756? Okay? It can be that, all right? And it more than often is. Okay? So it doesn't always work that you end up with these neat and tidy solutions. So what I'm going to do between this and the start of your next lesson is show you methods to solve any type of quadratic. So this method here is called completing the square. This method forms the basis for what's known as the quadratic roots formula. Okay? The quadratic roots formula I will derive in your next lesson, but I'm going to show you the method that we're going to use to do what's called completing the square. What it relies on is if you have the x squared term, if you have x squared is equal to some number k, you can solve for x, okay, by taking the square root. But if you do that, you end up with two numbers, because when you take the square root, it can be the positive number or a negative number. Because if you had, let's say the number was 2, okay? So 2 squared is equal to 4, right? And that's a positive number. But negative 2 squared is also equal to positive 4, right? Because this is actually negative 2 times negative 2. And a negative multiplied by a negative is a positive number. So we have no way of knowing whether or not it's a positive or negative number. So what we end up with here is two roots. In other words, we have positive times the square root of the number and the negative times the square root of the number. And those are known as the two roots. That becomes important not only when we talk about completing the square, but also when we talk about the quadratic roots formula. Because what you'll see is you always end up having two roots, okay? So for these x squared functions, you saw in the previous picture when I showed you how it was graphed, okay? It looked like a parabola, okay? So in other words, a parabola like this. So they always cross usually at 2 points, okay? So that's why it's important, this positive and negative. This forms the foundation for what we're going to do in the rest of the lessons. So in order to complete the square, there's a couple steps that we have to take. I'm going to explain how to perform those steps. If you want to know why any of those specific steps happen in terms of how it was derived, you can ask me by sending me an email or just follow along kind of with what I'm doing here. So to complete the square, what we do is we're always, remember, when we were trying to factor, we were always trying to have everything on one side of the equation. In this case, we're going to do something a little bit different. Instead, we're going to have the two terms that have x, okay? So in other words, the x squared term and the x term on one side. And the term with a constant, in this case the negative 4, we're going to move to the other side of the equation. So that's your first step. So if you do that, moving the negative 4 to the other side, it becomes positive 4. And we're left with 2x squared plus 8x is equal to positive 4. Now what we're going to do, our second step, is to make sure that we do not have a coefficient behind our x squared term. So in this case, we had a 2. So we're going to remove that by dividing every single term by 2. So if we do that, we have 2 divided by 2, which would give us 1. 8 divided by 2, which gives us 4. And 4 divided by 2, which gives us 2. Note that it's not always going to work out to these whole numbers. When we do examples, you'll see it where you keep it as a fraction. Okay? So now what we're left with is x squared plus 4x equals 2. Okay, so no constant or no value behind the x squared term or no coefficient. and we have the constant on the right-hand side of the equation. So now that it's on the right-hand side of the equation, what we want to do is we're going to focus now on the x term, okay? So again, that middle term in the equation that just has x, it's not x squared. What we want to do is take that coefficient, in this case it was 4, and we want to find half of it. Okay, so our first step is to find half of it. So 4 divided by 2 gives us 2. Our second step is to take that number that you find and you square it. So it becomes 2 squared, which gives us 4. Okay, it happens to be the same number. Again, not always going to be the case. This is a special instance because it's 4 divided by 2. When you do that, you then add that to both sides of the equation. Again, if you want to see the derivation for why I do this, you can ask me. But in this case, just trust as to why I'm doing this. What we're left with is x squared plus 4x plus 4. And again, since you're adding something to the left-hand side, you have to add it to the right-hand side. So on the right-hand side, that's equal to 2 plus 4. So what we're left with is x squared plus 4x plus 4 on the left-hand side equals 6. So the reason you take half is because what happens is it allows you to have a perfect square on the left-hand side. In other words, you can factor, using this method, the left-hand side, using two identical terms. Okay, so it becomes x plus 2 squared. Because if you have x plus 2 squared, that's x plus 2 times x plus 2. Okay, so all I did was factor this term to that. And if you want to check it, you'd use FOIL. So the first terms, x times x is x squared. The outside terms, x times 2 is 2x. The inside terms, 2 times x is 2x. And the last terms, 2 times 2 is 4. So this gives you x squared plus 4x plus 4. So using this method, you will always end up with factors on the left-hand side that look like this. In other words, two identical factors. Okay? So now to solve this, we can take the square root of both sides. Again, remember the formula we're relying on. Okay? That if you have x squared is equal to k, x is equal to plus or minus the square root of that number. So that's the same thing here. We have x plus 2 squared. And on the left-hand side, we're left with just x plus 2. Okay, not whether it's, in this case, we don't have whether it's positive or negative because we're actually taking the square root of something that's already squared. Okay, so we don't have whether it's positive or negative. So we're left with x plus 2 is equal to plus or minus the square root of the right-hand side, which was the square root of 6. Again, you can have two possible solutions here. So what we have is our final equation looks something like this. So in order for this to be true, we either have that x is equal to positive the square root of 6 minus 2, or the negative square root of 6 minus 2. Again, we have a minus 2 because we've moved the 2 to the right-hand side of the equation, which means it becomes negative 2, in order to just solve here for x. So completing the square gives you two factors using this method. And again, it does not matter whether or not the left-hand side can be factored initially. Usually this is used when it can't. And then you can see using this method, we turn it into a form that can be factored. All right? Okay, so using the completing the square method, I'm going to go through 3 examples. Okay? First example is solve x squared plus 4x minus 12 equals 0. Okay, so following the same steps, our first step is to move the constant to the right-hand side of the equation. So negative 12 becomes positive 12. And we have x squared plus 4x is equal to 12. Okay? Our next step would be to divide all the terms by the coefficient behind the x squared term. In this case, we don't have a coefficient, so we don't have to do that. Okay? It's only when the coefficient is not 1. Our third step is to look now and focus on this middle term here. Okay, so we take the coefficient from the x term and divide it by 2. So the coefficient is 4 divided by 2 is equal to 2. And then we take that term and we square it. So we take 2 squared is equal to 4. And we add that to both sides. And if we do that, we're left with x squared plus 4x plus 4 on the left-hand side is equal to 12, again, plus 4. What you do to one side of your equation, you have to do to the other. So now what we have is on the left-hand side, we have what's known as a perfect square. Okay, and this is always going to be the case when you use the completing the square method. The goal is to get your left-hand side as a perfect square. So if we do this, we end up with two factors factoring this, okay? So it has to multiply to positive 4, and it has to add to positive 4. In this case, there can really only be one option, plus 2 and plus 2. So they multiply to positive 4, and they also add to positive 4, okay? Add 2, multiply 2. So knowing that those are the factors, we can substitute them in, and we get x plus 2 squared is equal to 16. So now to solve for this, we take the square root. So if we take the square root of both sides, the square root of x plus 2 squared is equal to the square root of 16. So we're left with just x plus 2 is equal to either positive or negative of the square root of 16, which is 4. So solving for this, we either have that x is equal to, okay, actually before we do that, our step will be to solve for x on its own. So if we do that, we have to subtract 2 from both sides. Remember, because we're moving the x to the other side of the equation. So the negative 2 and positive 2 cancel, and we're left with x is equal to plus or minus 4 minus 2. So it can either be that x is equal to positive 4 minus 2, or x is equal to negative 4 minus 2. Okay, so in the first case, that's 2, and in the second case, it's negative 6. Okay, so your two options here are either x equals 2 or x equals negative 6. So remember, when we solve for this, those are actually the x-intercepts. Okay. Okay. So our second example, solve x squared is equal to 16. In this case, it's easy. We don't have an x term in the middle, and we don't have to, right? We basically can skip those steps. We don't have a coefficient behind the x term, okay? And we don't have an x term. We don't have a 3x or a negative 4x or something like that. So we can simply just take the square root. And if we do that, we have x squared, the square root of, is equal to the square root of 16. Okay, so the square root of a term that's already squared is simply just the term, so x. And in this case, it's equal to just plus or minus 4. Okay, so it's the same as our previous question when we get to our final answer, except we don't have another term to consider here. So x in this case is either equal to 4 or x is equal to negative 4. Okay, so I show you this example because you don't have to have a term with just x in there. Okay, it can just simply be written like this. Okay, so our last example is solve 6x squared minus 12x minus 14 equals 0. So we're going to follow the exact same steps. Okay, our first step is to move our constant to the other side of the equation. So negative 14 becomes positive 14 on the other side, and we're left with 6x squared minus 12x is equal to 14. Now, we have to remove the coefficient behind the x squared term, and we do that by dividing every term by 6. If we do that, 6 divided by 6, okay, so we have just x squared, minus 12 divided by 2, or divided by 6 is 2, so minus 2x. is equal to 14 divided by 6, we can write in lowest terms as 8 divided by 3. I don't like carrying these as repeating decimals, okay? It makes it more difficult to do the math, because 8 divided by 3 is actually 2.666 as a repeating decimal, which would be 2.6 bar, okay? I don't like showing it that way. 8 over 3 is a much simpler term to carry through. So now I'm going to follow the exact same steps, okay? So we focus on the coefficient behind the x term, and we take that coefficient, -2, and we divide it in half, so divide it by 2, and that gives us -1. Then we take that term, -1, and we square it, and that gives us +1. And we take that value and we add it in on both sides of this equation. So this becomes x squared minus 2x plus 1 is equal to 8 divided by 3 plus 1 again. Okay? Again, you have to do what you do to one side of the equation, you have to do it to the other. So just like I said in the past, you end up with a perfect square on one side of the equation, the left side. Okay? And the perfect square is always going to revolve around this value you calculate here. So your perfect square on the left-hand side becomes x minus 1 squared. Okay? And your right-hand side, adding those two up, 1 over 1 is the same as 3 over 3. So it becomes 8 over 3 plus 3 over 3, which gives us 11 over 3. Again, I like to work in fractions instead. So moving this over to here, we have x minus 1 squared is equal to 11 over 3. So now solving for this, we can take the square root of both sides. And the square root of a squared number is simply just what's in the brackets, so x minus 1. And that's equal to plus or minus the square root of 11 over 3. So our last step to solve for x is to move this -1 to the other side, so it becomes +1. And we have that x is equal to plus or minus the root of 11 over 3 plus 1. So that means that x can either be the positive root 11 over 3 plus 1, or x can be equal to the negative root of 11 over 3 plus 1. Okay, so you're always going to take that root and do either the positive or the negative. Okay, so you can actually find those solutions if you want, or you can leave them in fraction form. Either way is totally up to you. Okay, so that was all I had. If you want more practice specifically on completing a square and factoring, I recommend that you look at these practice problems. I've noted for you to do the odd numbered problems only, and that's just because more of the solutions to those are in the back of your textbook. So if you have any questions, please send me an email or come to a tutorial session. Thanks, everybody.